In this video, we're going to try and find the power series representation of this. So we're going to try and seek the power series representation of this. But the way we're going to do that is we are going to seek the power series representation of this. So that would give us this thing here. But the thing is, if you differentiate this, it will give you this thing here. So we're going to try and seek this power series here. Once we've got it, then we can differentiate this to give us what we want, which is this. So realize that when you differentiate this, it will give you this. Because if I were to ask you to differentiate this, in your mind you would visualize it like this: 1 minus 2x to the power minus 1. And when you differentiate this, the power goes down here, so that would be negative 1, and then the bubble here stays intact, so that will be 1 minus 2x, and then this gets minus by 1, and then you times the derivative of the bubble itself, which will be negative 2. So merge these two together, that will be a 2 over, well, don't forget this is negative 2 here. That will then give you this, which is exactly the same as this. So the way we're going to seek the power representation of this is we're going to try and seek the power representation of this. That will then give us this thing here, and then later on, if you differentiate this, it will give you this. So therefore, we can differentiate this to give us what we want. So we are trying to seek this here. Okay. So before we do that, realize that that if you have a power series like this, if you differentiate it, so this is f of x equals this thing here. We've done this before, so you should already know this. If you differentiate this, it will give you this. So when you come to differentiate this, the n goes down. This is it's like a constant. So the n goes down. So that will then give you this. The bubble stays intact. The bubble stays intact, and then the power gets minus by 1. So the power gets minus 1. And when you integrate it, so from here, if you integrate it, the power gets increased by 1, but then you've got to divide it by n plus 1. We've seen this before, so bear this in mind. Okay, so let's start again. We are trying to seek the power series representation of this, but we're going to seek this first, and then later on we can differentiate it to give us this. So looking at this, and again you should already know this. This is your a here. This is your a here. Well, this is the same. So our common ratio here is 2x. So what that means is, if we put this into here, remember a is 1, so this is like 1 here. So this will be so our series will be 1 plus. Well, put this into here, so that will be 2x, and then put this into here. Don't forget a is 1. Okay, so put this 2x into the r here, square it. That will then give you 2x squared. Put it into here. That will then give you 2x to the power 3, and so on. So looking at this function here, we can translate it into this form here. So looking at this function here, we can translate it to here. So once you're here, you can translate it back into a summation form by looking at this, by imagining this as being 1. So this is like a common thing that keeps on recurring. So it's going to be 2x, and then look at this, n 1, 2, 3, and so on. So if you make it like this, then that will then take you to here. Okay, so translate this into this. So now we've got our f of x here. Remember, hang on, let's go back to here. We are trying to seek the series power the power series representation of this. But before we do that, we would seek this. And now we've got our f of x. We've got our f of x now. This here is our f of x. So now we just need to differentiate it. So we need to differentiate this. So when you differentiate this, the n goes down. That will then give you this. The bubble stays intact. The bubble stays intact. The n gets minus by 1, but then you times the derivative of the bubble itself, which will be 2. So if you just look at this term here, if you differentiate this, this will come down here 3. The bubble stays intact, and then the power gets minus by 1, and then you've got to times the derivative of the bubble itself, which would be 2. So this 2 here is this 2 here, and then the bubble here is this bubble here, the 3 here is this n here, and so on. Okay, so if you differentiate this, it will then give you this. Now, tidy this up, that will then give you this. So when you differentiate f of x, it gives you this. Remember, what f of x is this thing here. When we differentiate f of x, it gave us this thing here. So we can say that this thing here is equal to this thing here. Okay, so this thing here is equal to this thing here, because if you differentiate this, it gives you this. So we can say this thing equals this thing here. So we can say this thing here equals this thing here. So now this here is our power series representation of our function here. Okay.